Okay, now we'll learn how to break a vector into its components. Suppose this is given as a vector. Now I draw x-axis and y-axis. X-axis and y-axis are 90° with each other. So let's see. So I can say that this vector is if I add these two vectors we'll get a vector. So I can say that a vector is, suppose we say this is ax and this is ay. So we can write it as a vector is equal to ax I cap, because this direction is I cap. Unit vector along x axis is called I cap, and ay j cap, because unit vector along y cap is called j cap. So this magnitude is ay. So I can write a vector as ax I cap plus ay j cap. So these are called components of a vector. Okay, what will be ax? Suppose this value is theta. So then cos theta means base by hypotenuse. So that will be ax by magnitude of a vector. Suppose magnitude of a vector is a, then it will be ax by a. Otherwise x, therefore x will be a cos theta. Similarly, sin theta will be equal to height by hypotenuse, so that will be ay by a. That means ay will be equal to a sin theta. So a vector will be a cos theta I cap plus a sin theta j cap. So I can break any vector in its rectangular components as x I cap plus ay j cap. It can be any vector. If it makes angle theta with x-axis, then that will be a cos theta I cap plus a sin theta j cap. Okay, so with this concept we can add many vectors. We'll see that. Suppose now I have given you the same problem, that add a vector and b vector. So now we will not follow law of triangles or law of parallelograms. Instead we will break these vectors into components. Suppose a vector is not along x-axis. Suppose say a vector is this axis. So now we will not follow law of triangle or law of parallelogram. Instead we will break these vectors into rectangular components. This is x-axis, this is your y-axis. Suppose we will draw first a vector and we will break into x and ay. Suppose if this is theta, if this angle is theta, then it will be a cos theta and this will be a sin theta. Similarly we can break b vector also. Okay, so in this way if we try to add these two vectors, it will be a vector will be a cos theta I cap plus a sin theta j cap, and b vector will be, suppose this angle, the angle B vector makes with x-axis is phi, then it will be B cos phi I cap plus B sin phi j cap. So along x-axis the components will be only ax and bx, so that is x plus bx I cap plus ay plus by j cap, that is a cos theta plus b cos phi I cap plus a sin theta plus b sin phi j cap. So in this way, if suppose I have given you to add many vectors, suppose this C vector, suppose this is D vector, suppose this is E vector, suppose this is F vector, so you can take a rectangular coordinate and then you can draw these vectors. Then you can find x components of every vectors. Okay, suppose ax plus bx plus cx plus dx plus ex plus fx, all these components you can find, and this will be, suppose say rx, this value, and similarly you can find y component of every vector. You can find y component of every vector. So suppose those magnitudes, those y components will be ay plus by plus cy plus dy plus ey plus fy, and these will be just values, those will be just magnitudes values, so you can easily add them. Okay, this dy is this dx, ex and fx, these values will become negative as these are in negative along negative x-axis, so these values will be negative, dx, ex and fx. Okay, then you add them and the final product, the final r vector, the resultant vector will be rx I cap plus ry j cap. That means the magnitude of r will be root over rx square plus ry square, because the resultant of these values, rx will be along x-axis and ry be along this axis, so the resultant of these two will be r vector. And the angle it will make, suppose this angle is psi, then tan psi will be ry by rx. You can find value of rx and ry from this formula. So in this way effortlessly you can add any number of vectors. Okay, now say what will be a vector in 3D? Vector in 3D. In 2 dimension we have seen only I cap and j cap, that is x-axis and y-axis, but in 3D we'll see and another axis, and these are always 90 degree with each other. That's why these are called rectangular coordinates. Now suppose see, this is your x-axis, suppose say this is your x-axis, this is your y-axis, these are in the plane of board, okay, and 90 degree with each other. So if this is x-axis and this is y-axis, then this will be z-axis. That means suppose say if this is x-axis and this is y-axis, that means if this direction is x-axis, this direction is y-axis, then this upwards direction will be z axis. This is x axis, this is y axis, then z axis will be along this side. Okay, so in reality, in 3D, this will be x axis, this will be your y axis, and this will be your z axis upwards. Okay, now and see, all of these axes are making 90-degree angle with each other. This angle is 90 degree, this angle is 90 degree. Okay, and this angle is also 90 degree. X, y and z all makes angle 90 degree with each other. Now in 2D, if I try to draw 3D, okay, then we draw like this. This is our x axis, this is y axis, and this is x axis, this is y axis, and this is z axis. So this is 90 degree, this is also 90 degree, and this is also 90 degree. In 2D, actual drawing of 3D is not possible, it's imaginary. Okay, so you have to imagine that the angles between these axes are this x, y and z all are making 90-degree angles with each other. Okay, so this is 3D. So if in 3D, if you draw a vector, suppose in 3 dimension, this is your x axis, y axis, z axis. Unit vector along x axis is I cap, unit vector along y axis is j cap, unit vector along z axis is k cap. So now if you draw a vector, suppose say this is a vector, and if you break into components, then this is along x axis, this is ax, along y axis this is a y, and along z axis this is a z. So a vector will be ax I cap plus ay j cap plus az k cap. Okay, first if you add this ax and ay, first if you add this ax vector and ay vector, then ax I cap plus ay j cap, then with parallelogram law you will get this vector, and then if you add this az k cap, this az k cap, then you will get a vector az k cap. With this, if you add az k cap, then you will get a vector. And magnitude of a vector will be root over x square plus ay square plus az square. Okay, why so? Because this magnitude, you know, suppose this is, suppose say this is axy, then axy will be root over x square plus ay square. Okay, so that, and s square will be, these are 98, this z az cap is 90 degree with xy plane, so these are 90 degrees with each other, so s square will be axy square plus ay square, and axy square means x square plus ay square. Sorry, this is az square plus az square. So s square equal to x square plus ay square plus az square, then a means root over x square plus ay square plus az square. So in this way you can find it. Okay, thank you.